And I threw this on the calendar. What we're looking at doing, yes, sir.
Do we need to keep these?
No, you can save it if you want. It doesn't matter to me. Sure. So one of the things I wanted to make sure you guys had up to date is on the calendar. So in the calendar, I've already scheduled us through that. We're going to get through all of 5.2 today. We might have a lingering little bit of 5.2 left tomorrow. 5.3 is ridiculously simple. 5.4 is where we start talking about imaginary numbers. Now, notice, I'm using the old textbook for this unit. The old textbook has some better style problems for what I'm looking for you guys to be able to do versus the new one. So I'm going to supplement some of the materials here. Now, on the website, I know by now you guys have already recognized that where we have it where it says old book. I know last week I accidentally, none of those were viewable, but now they are. So I've kind of been throwing them in here and just writing down the homework problems on the side there. So everything's going to be there for us underneath old book. Hopwork, what do you got?
So last week, like, you couldn't access the...
For some reason I didn't change, I forgot to change the setting on it on Thursday, but then by Friday everything was up and going.
I went on, like, my mom's phone and was, like, looking at it, except I couldn't click it in, so I went to, like, where it says click your gold stuff, and then I found it on your page.
Oh, it should have just been underneath the old book, but, well, good, you were resourceful. Eric 5 for Hopwork.
You don't
That's
make
like
any sound effect.
Yeah. Slap.
Whatever. So, factoring. I know that there are so many different ways to set up factoring. People use that box method. People have used multiply the tails, add to the middle, the T-chart. There are so many, guess and check. There is the idea where we do GCFs, grouping. I call it split middle term, things like that. There are so many different ways to do it. I only do it really one way, and that is, I'll show you. If I want to factor x squared minus 12x minus 28, I figure out what times what's negative 28, and I add together to get negative 12. I use that T-chart. I use my factors. I use my multiplication knowledge that my factors of negative 28 are negative 1 and 28, 2 and 14, 4 and 7. And I go through that. And I look to see, is there some, did I forget one?
No, you got them all.
Yeah, sorry. And then I look to see if there's some sort of a combination of any one of those that gives me a negative multiplier and a negative addition. Yes, ma'am?
Would that be, like, foil?
I'm unfoiling. I'm looking to figure this out to be what are the two terms and I multiply together. Yeah, it's the x and x plus 2 and the x minus 14. Okay, bless you. What's that? Correct. Yep. Now, one thing you'll recall is that if you have something that's being multiplied to become negative, that means one of them's positive, one of them's negative. If the middle term is negative, that means the larger of the two numbers is also negative. If the middle term was positive, the larger of the two would have been positive. These are what we call terms. Terms are always what is going to be in parentheses. Zeros, on the other hand, is when it looks like this. If this problem said x squared minus 12x minus 28 equals 0. Because then this problem is asking you, where does this parabola cross the x-axis? For what values of x do you get 0 for y? Lori?
Wait, so you, oh no, I was answering. So you have to add those together to get negative 12, right?
Yeah.
Okay.
Yes, sir?
It'd be 14 negative 2.
Yeah, exactly. So if you had to set up a problem where it says solve the equation, the quadratic would equal 0, you do the exact same thing, but then your two zeros would be at negative 2 and positive 14. So we have zeros and we have terms. What's up? We did this a little bit last year. We had like 4 or 5 problems in geometry, especially circles. Circles, you have that outside times the whole, one of the quadratics a lot of times. That was really the only time in geometry we had that. Yes, ma'am?
So
Those are heavy.
the last number is always the one that you multiply with the number 2?
Yep. Multiply the tail to add in the middle. Same thing here. X squared or 4x minus 21. And the idea that if you know your
I got it first.
Thanks, Anna would get it.
Anna's a jerk. Because again, if you know your factors, life is quicker to multiply. It's quicker to set it up. So, ladies and gentlemen, come on. So, what is this factor 2?
I got 7 -3.
I'm not fighting over you guys anymore. I'm sick and tired of having to tell you every single day to stop talking. Okay? What were your terms? Does it matter which one goes first? Nope. If this set equals 0, what would be your zeros? Negative 7 and 3. Where does this? Oops. Where does it cross the x-axis? Negative 7 and 3. Yeah. Remember, when I ask for zeros, it's the same thing as the x-axis intercepts. It means the same thing. I'm actually kind of setting you guys up for something we do later on by taking you through these extra steps, because eventually what we're going to look at is that we're going to factor higher degree polynomials, like 6-degree polynomials. A 6-degree polynomial could have 6, 5, 4, 3, 2, 1, and a constant. It could have 7 terms to it. We can factor all of that out, and there's a very, very easy method to do so. Yes, sir?
So if the order of like which you put in the 7 and 3 doesn't matter, how many of the
It's where it's crossing the x-axis. Now, if you FOIL this out, you're going to get x squared minus 3x plus 7x minus 21, which is x squared 4x minus 21. If you go the other way, you FOIL that out. Don't you get the same thing? It doesn't matter. It does, because you're multiplying, and when 2 times 3 is the same thing as 3 times 2. It works out just fine. The zeros here are the same zeros there. If they're not, you don't do it. Okay. The weird one comes into play then when you start having to do, oh, I don't know, let's look at this. Let's factor that. Why? Because the first rule of factoring is always to look for a
Greatest common factor.
always look for a GCF. So if I take a GCF out, what's the GCF? 2. Now, there's 2 things to this problem here. I'm going to ask this 2 different ways. If I factor this the rest of the way, what's going to end up being my 2 terms?
Negative 4 and 3.
Negative 4 and 3. Very good. So it's 2x minus 4, x plus 3. Now, that means it's fully factored. What changes if that was there? What is this asking me then? Where does x equal 0? So what are my zeros? 4 and negative 3. Does this constant out front make any difference to the problem? No. Because if you're solving for 0, if you're solving for x in this equation then, if you divide out by 2, doesn't it just go away? So when you have scalars, when you have that scale multiplier thrown in there, after you factor it out, if you're solving for a 0, it has no bearing on the problem whatsoever. Okay? Yeah.
So if you write x equals 4 and x equals 3, how would you like write that
As an answer, my answers would be x equals 4, comma, negative 3.
Oh,
Done.
so you never have to write it in like
Order
like
pairs?
when-
No, because if you wrote an order of pairs, you have to write 4, 0, and then negative 3 and 0. That's just too much work. Your zeros are at 4 and negative 3. X equals 4 and negative 3. That's fine. Okay? Does that make sense? Is this opening up or down? It's up. Will the vertex be a maximum or a minimum? A minimum. Lots of little bits and pieces you can ask out of these things. It's up like a cup because this value is positive. If it's up like a cup, that means the vertex is a minimum, and so on and so forth. Okay? Now, Now I'm only having 2 terms. Okay? When you have 2 terms, you have to ask yourself 3 separate questions. Seems like a lot, but the first one is pretty easy. Question number 1. Is x squared a perfect square? Yes. Question number 2. Is 16 a perfect square? Yes. Question number 3. Is that a subtraction symbol?
Yeah.
Okay, if you answered yes to all 3 of those, what are your 2 terms?
4, negative 4.
X minus 4, x plus 4. Okay? Now notice the difference between that and still has 2 terms. It's quadratic. Question number 1. Is 4x squared a perfect square? Is 9 a perfect square? Is that a subtraction symbol? Can I factor that? No. Can't factor it because it doesn't follow the pattern.
Right for that, just now
I'm sorry, what was that? Right. But did I say yes to everything?
No, I'm just saying like, yes. Like if it were an 8.
Then I know I couldn't do it. If it was an 8, well, hey guys, this is a great question. If this was an 8, what's your first rule?
It's not
But still, what could I do?
GCF.
I can take a GCF, right? X squared plus 2. Now that's factored. It's factored from here. So again, I took a GCF out. So the GCF is your first step of factoring. So even if it's unfactorable, if there's a GCF, you still take it out.
What if it's just like, what if it would be like 4x squared plus 3?
4x squared plus 3, then I say no. And I go to the next problem.
So if we just write no, and it's like,
Not factorable.
what's the pattern?
What's the pattern?
So there's,
There is a pattern.
what like determines if it's
Is this a perfect square? Yes. Is this a perfect square? Is this a subtraction symbol? If you answered yes to all 3 questions, it's plus minus the square root of that.
perfect squares and subtractions?
Miss Laura, you had a question.
Yeah. Do you have to put equal 0, like equal 0?
No, I don't have. Sometimes it might say equals 0 because if this said equals 0, what are my 2 zeros? Plus or minus 4. Done. That's all. No difference.
Okay.
Wait, so then with the other one, the 4x squared plus 3, you can't use right now.
Correct. Because you can't factor that yet. We will eventually be able to solve that, but we have to wait till Wednesday.
Oh, yeah.
Because we have to talk about imaginary numbers.
First there's regular numbers, then there's the alphabet,
Yes,
and
sir.
then there's imaginary numbers.
So if it was like 4x squared plus 8 and then you did the GCF, would you factor that out then?
Yes, you always factor out GCF. GCF is always your first line of defense. If that comes out, then if it doesn't go any further, then you're done.
So if it's like 4 times x squared plus 2, does the 4 count as anything? Like, you still...
It's just factor, 4x squared plus 8. If you take out the 4, you're done. There's nothing else you can do.
Okay.
If there was later on, Wednesday-ish, if it was equals 0, we can do something.
Okay.
But right now we can't. Okay.
Even though you can take out the GCF, that's not factored.
That is factored because you took out a 4, but now you're done. You can't go any further.
So even as GCF, even if there's a GCF, it's factored.
Yes, GCF is a factorable thing, but after you get a GCF out, then you're done. If you can't go any further. Okay. Now, the other one that we look at is this. Let's see. What does this mean? It means junk squared. Junk squared is what?
Junk times junk.
Junk times junk. Gee, where have you heard that before, Lori?
I don't know. You?
It means junk times junk. In other words, when you see something that is x plus 3 quantity squared, it is not x squared plus 9. Because if you do x squared plus 9, you have killed a puppy. Just like Seb said. Just like Seb said. This is right. You'd be surprised the amount of times that people forget that.
And you foil.
And then you spoil it out, right? Because in this case, this is the other special pattern. When you FOIL out, and you have a FOILed out junk squared style problem. Yeah.
When would be the time where you would distribute this?
Never. Well, if it's a monomial on the inside. Give us time, we'll show you. Now, this is the other special pattern. When you have special pattern, we can have another one that's called the perfect square trinomial. The way that this special pattern works is that if the first term is a perfect square, and the last term is a perfect square, but there's 3 terms total. What that means is, well, what's the square root of x squared? What's the square root of 9?
3.
So the middle term would be 3x, and then I double it, you get,
6 squared.
that's where you get this from. What happens is, if you look at this long form, oops, move this out of the way. This is x squared, 3x, 3x, and a 9. That's where we get this x squared plus 6x. That's double. It's repeated in the middle. It means it's the same thing twice. So if I have another one where it's x squared plus 10x plus 25, is that a perfect square? Is this a perfect square?
Yes.
What's the square root of that?
5.
What's the square root of that?
X.
So it's 5x and double it, what do you get? So it's x plus 5 quantity squared. Now, do you need to use that every time? What times what's 25? You add together to get 10. 5 and 5.
Like another way you could do it.
Yep. You can always fall back on that. T-chart will always fall back on it. Same idea. If it was what times what's negative 9, you add together to get 0. 3 and positive, or 3 and negative 3. Yes, ma'am.
Okay, so like why do we need like this, when you have that, are we gonna have like the 3 set up and we have to like bring it backwards, or will it just be like
You're going to be
explaining why
factoring.
this
You'll be factoring trinomials. There's so many different ways to do these. You can do it any way you want. Doesn't matter to me.
So like why do we need to go back to like what it was originally?
What do you mean?
Because like you know how we were going from like
Going-
that originally and then factoring it out, then why do we have to go backwards?
I'm showing you where this special pattern comes from.
Oh, I see, you're just explaining it. Okay,
That's all.
So the official like factored form of that would then be the x plus 3 squared.
Yeah. Or do you have to write it as x plus 3 quantity squared, or do you have to write it as x plus 3 x plus 3?
Maybe.
Either. Exactly. Everybody hear that? When you have junk squared, if you wind up factoring out x plus 10x plus 25 and it's x plus 5, x plus 5, do you have to write it as x plus 5 quantity squared? No, you don't. You don't have to do it at all. Okay? It just means that it has 1, 0. It only touches the x-axis at one spot, at negative 5. That's all it does. Okay? Now the other one that people tend to forget about is this. First term not equal to 1. Factor this with first term not equal to 1. Yes, sir. And again, I know that there are so many different methods to do this. I always fall back on what I was taught because I know that it might be a step or so longer than other methods, but I know it's always going to work, okay? So what I do here is I factor this by grouping. Other people call it split middle term. It just takes, it's actually just one extra step than other methods that the book shows, but I think it works really clean. And here's how we do that. You take the first term times the last. What's 3 times 10?
30.
So what times what is positive 30? You add together to get negative 17. Okay? So what we're doing is we're going to rewrite this middle term as 2 terms. 3x squared minus 15x minus 2x plus 10. And what I do from here now is since I have 4-term polynomial, I'm going to factor it by grouping, just by throwing parentheses around the first 2. And I'm going to take GCFs out. What's the GCF? 3x squared and 15x. 3x. Good. It's 3x. So I take out a 3x and I'm left with x minus 5. Now here's the trick of this problem. When you factor out the second part, You want the parentheses to be the same, because then those two terms share the same factor, which means it can be factored out again. So I need to factor out, this is another shortcut that I'll show you. Anytime this third term is negative, make sure you bring out the negative right away. What's negative 2 divided by negative 2? 1. And 10 divided by negative 2 is? Now are these two the same? You write it down. And what are you left with? 3x minus 2. It's literally one step longer than most methods, but it forces you to see where things are coming from. And it's much easier than most other methods that I've ever seen. Sure. Let me see if I can think of one. They should be. If they're not the same, then you're probably goofed. Yes, ma'am.
So then would the x be x 5 equals 5 and like 2 over 3?
Perfect. That's it. Yeah, because then that's where I was going to go next. If I do this and I set it equal to 0, then I set both these two equal to 0, which means it's 5 and 2/3. Those are my zeros. Okay. Let's see if I get another one here then. So let's see. This is 5. All right, same deal. So if I want to factor this, I have 3x squared minus 8x plus 4. Should we take 4x? No, I can't drink water. I've got a hole in my mouth. Set it up the exact same way again. 3 times 4 is 12. Well, so we do what times what is 12 to add up to get negative 8. 6 and 2. Now, I need a 6 and 2. Are they both positive, both negative, or mixtures? Both negatives. Very good. So I have a negative 6, negative 2. Now, does it matter which one I put first? No. I will recommend this. If you have a positive and a negative, put your negative first. If they're both negative, just good luck. Now, I mean it. What happens is that a lot of people will forget that this is negative when they're doing the work, and they forget to undistribute the negative there. Right? That's usually the problem. Yeah.
Yeah, it's gonna be squared.
It was. You just had to squint. Take the GCF. What do you got? They got the 3x. We wind up with the x minus 2. Again, what am I going to take out of that? The negative 2. Very good. Are these two the same?
Yes.
That means we're probably doing okay. X minus 2 and 3x minus 2. If it was equal to 0, my two zeros would then be 2 and 2/3. You were asking how to write this out a second ago, Hopworth. If I'm asking you for zeros, if you get this far and it's equal 0, you just list them. That's fine. That's okay with me. Okay. It doesn't have to be specific points. You don't have to say, oh, x equals blah, blah, blah. If you have it written down, I'm okay. It's a lot of multiplying and adding, multiplying and adding, multiplying and adding. It's stuff like that. There are so many different ways of going about doing these things. There's so many different ways to set these things up and to try them through. It's a matter of just finding a method and just kind of sticking with it. Yeah, Lori?
This is all we're doing.
Yes, ma'am.
Wait, don't change it.
Not changing it, waiting patiently.
Alright, while we're waiting, can I ask you, on the homework last night, it had like a thing with like graphs, and it said like graph thing where it was like 5, and then less than, and then x, and then less than another number.
All that meant is you're looking at the window, your X window range
So you
between
had, like,
8.
a box?
That's all it was. You're just looking at that one little section of it. That's all.
Alright, it's like, it said, it needs something like, it was like popcorn, and it's like.
You were looking
something
at,
that-
I think you were looking at the 2 different graphs within that range to see which one was higher. That's all.
Yeah, I
Because you
know.
could plot them at the 2 different Y values in the calculator.
Okay, that's what I thought.
That's all it was. And we're actually going to do more of the calculator stuff with the comparisons of interval stuff. And like 5.7 or 5.8. It's towards the end.
Like I knew what I was trying to do, but I like didn't understand. Like,
And that's okay. We'll look at more of the interval stuff when I bring back all the word problem stuff at the same time, because it becomes really calculator dependent at that point. Yes, sir. I don't know, like 15. There's something.
It's like 24 to 88.
Yeah, it's real
Every
fast.
other, every four.
It's every other.
One thing the book does all the time that kind of drives me nuts, they change the value, like X's all the time. They change it to Y's, R's, S's, T's, Q's, P's, whatever. Does it matter? No. Usually, more often than not, when I'm writing the problems down, I usually wind up using X anyway. I'll say, oh, it's 9X squared, 24X, and it's 16. So this is one of those questions that when I see this, I automatically recognize that 9 is a what?
Square.
It's a perfect square. So like, wait a second, it's a perfect square. What about 16? Is 16 a perfect square?
Yes.
All right, what's the square root of 9?
3.
What's the square root of 16?
4.
What's 3 times 4?
12.
Double it.
24.
What's your answer?
24.
Done. The reason that works again. Yeah, you can do it the long way. What's 9 times 16? It's 144. What times what is 144 that you add together to get 24?
12 and 12.
Convenient, isn't it? And can't you still get GCFs?
Yep.
It's a 3x. What do they have in common?
2.
4?
4.
Oh, there's a 1 here. My handwriting is sometimes great.
Never.
Shut up.
That was quite rude.
See how it's the same thing twice? We wrote it down. We're left with the same thing. Works. Yep. There are many different ways to set these things true. So if you don't want to go, if you want to do a shortcut just by recognizing pattern, you don't have to. You can math more if you want. Math more, we'll make more. I got it. Okay. So yeah, again, the homework stuff is on that. It's that section 5.2 in the old book. What is it? Page 260 something? It's already in the calendar and all that. So it's 260. Yeah. What I say? 20. What was it? 24.
24 through 88 by 4.
You guys understand what I mean by fours, right? Every other even. 24, 28, 32, 36. Hey, you just did a times table, so if you look at your fours and you start at 24, if you did it correct, you know about half of it. No, you didn't.